All right, if we look at question number 3, we have a company designs spinning toys using the family of functions y equals c times x times the square root of 4 minus x squared, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of y equals cx times the square root of 4 minus x squared for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved around the x-axis. Both x and y are measured in inches. Find the area of the region in the first quadrant bounded by the x-axis and the graph of y equals cx times the square root of 4 minus x squared for c equals 6. So the first thing that we're going to need to do is we are going to need to figure out where that function intersects with the x-axis. So I'm going to do that by taking my equation and setting it equal to 0. So I'm going to say 0 equals, and remember c was 6, so we have 6x times the square root of 4 minus x squared. And now we just need to solve for x. We can solve for x by taking both of these factors, 6x and the square root of 4 minus x squared, and setting them equal to 0. So let me finish. There we go. Right, so we know if we were to solve for this, we know that we are going to have two answers. Right, we're going to have x equals 0 and x equals 2. So we know that we're trying to find the area underneath the curve, and it's bounded by the x-axis, which is our horizontal axis. So we need to, if we want to find the area under the curve, we need to integrate. So we're going to do an integral from 0 to 2. And we're going to take our equation of the curve and solve for it from 0 to 2. Now, to take the antiderivative of 6x times the square root of 4 minus x squared, we are going to have to use u substitution. So remember, for u substitution, we typically make the inside function our u values. So in this case, I'm going to say u is 4 minus x squared. And then I need to go ahead and find the derivative of that. So du, okay, the derivative of 4 is just 0. And the derivative of negative x squared is going to be negative 2x dx. And so there's my u and du. All right, so with u being 4 minus x squared, then I can rewrite this. I can replace that 4 minus x squared with u. All right, du is x dx. So the du is going to replace that x and my dx. So anything that's not in u and du, I'm going to need to keep. So I'm going to need to keep that 6. I'm also going to need to keep that square root. We also have a negative 2 right here, right, that is not part of our equation. So I'm going to have to get rid of that. And to get rid of the negative 2, I can just multiply by a negative 1/2. So when we go ahead and rewrite this integral in terms of u and du, I pulled the 6 outside of the integral. So I ended up with 6 times negative 1/2 times, and I integrate from 0 to 2, the square root of u du. I'm going to go ahead and rewrite the square root of u as u to the power of 1/2. It makes it easier to find the antiderivative. And when I take the antiderivative, remember that negative 1/2 times 6, that gives me this 3 right here. I add 1 to that exponent of 1/2, which gives me 3 over 2. Multiply by the reciprocal, how I get that 2/3 right there, and I do end up with negative 3 times 2/3 times u to the power of 3 over 2. Notice these 3's will now cancel out. And so I'm left with just negative 2 times u to the power of 3 over 2. All right, now we've got to replace u with 4 minus x squared. And so not only did I replace u, but I went ahead and rewrote it for algebra purposes as, instead of the power of 3 over 2, I wrote it as 4 minus x squared. I take the square root of that and then cube it. All right, so now we're going to solve. We're going to plug in our b minus a and see what our answer is. So I'm going to replace x with 2 first, so I still have that -2 out front times the square root of 4 minus 2 squared cubed, and then I'm going to replace x with 0. So I'm going to say minus the square root of 4 minus 0 squared cubed. All right, and so when I do this, I have my -2 out front still. 4 minus 2 squared ends up just giving me 0. So I have 0 minus, and then 4 minus 0 squared is 4. The square root of 4 is 2, and 2 cubed is 8. So I end up with 0 minus 8. Right, so -2 times -8 gives me 16, which is my area. My area is 16 inches squared. All right, if we look at part B of this question, it says, it is known that for y equals cx times the square root of 4 minus x squared, dy over dx is equal to, and they give us that equation. So for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of c for this spinning toy? So remember kind of what I always say, go back to kind of the basics of the question. They're telling you that the largest cross-sectional circular slice, right? Which, if we think of that, they give us the largest cross-section. So in other words, they're giving us a maximum, right? So let's find the x value for the maximum. We know we're going to have a maximum whenever the derivative equals 0, which means we can set dy over dx equal to 0. Now remember that whenever a rational equals 0, that means the numerator is equal to 0. So to make this a little bit easier for me to solve, I'm just going to take the numerator, c times 4 minus 2x squared, and set it equal to 0. I can start off by dividing out that c. So if I divide out the c, I just have 0 equals 4 minus 2x squared. I can move the 4 over, which is how I get -4 equals -2x squared. I can divide out that -2, and I can square root it, and I end up with x equals the square root of 2. Now that I know the x value, I have the entire point, because they tell us that the radius is 1.2. So we know that the maximum is at the point square root of 2, comma 1.2. Now we can go ahead and actually plug that point into our equation for y equals c times x times the square root of 4 minus x squared, and we can solve for c, which is the goal of this. What is the value of c for the spinning toy? So I replace x with the square root of 2. I'm going to replace my y with 1.2, and I solve. All right, when I do that, the square root of 2 squared is just 2. Okay, 4 minus 2 is 2. So we have the square root of 2 times the square root of 2 times c equals 1.2. Well, the square root of 2 times the square root of 2 is just 2. So we have 1.2 equals 2c, which gives us 0.6. And c is 0.6. That's our answer. All right, if we look at part C, for another spinning toy, the volume is 2 pi cubic inches. What is the value of c for this spinning toy? All right, so first of all, if we want to find the volume, remember that means we are going to find the area, all right, by adding up all of these cross sections that we have underneath the curve. So if you look at what we're given, right, we're given the fact that the volume is 2 pi cubic inches. They tell us that in the problem. We know the radius is y equals cx times the square root of 4 minus x squared. Right? And since we want to add the area of all these cross sections, we're going to need to integrate. Now, since we're finding the volume, I'm going to go ahead and start off by saying 2 pi equals, because we know that is the volume. We're going to integrate from 0 to 2. And since we're finding the volume of these cross sections, we're going to take pi times the radius. And in this case, we know our radius is cx times the square root of 4 minus x squared. And then we square that radius. All right, I'm going to go ahead and pull that pi outside of the integral, so I end up with 2 pi equals pi times my integral. And notice I have a pi on both sides of the equal sign, so we know those are going to cancel out. Right, and then I'm going to be left with 2 equals the integral from 0 to 2 of my radius squared dx. Right, now if I want to go ahead and actually start to solve for this, I'm going to distribute that squared. So when I distribute the squared, I am going to end up with c squared times x squared times 4 minus x squared. The squared and the square root cancel each other out. Right? And I can go ahead and pull out that c squared again because remember that's just a constant, so I'm going to go ahead and take it outside of the integral. I can now go ahead and distribute. What I'm doing is I'm taking that x squared that's being multiplied to the 4 minus x squared and I'm going to distribute it in. And when I do that, I end up with 4x squared minus x to the 4th dx. And now it's going to be a lot easier for me to integrate in the form that I have this equation. Right? I can go ahead and find the antiderivative of 4x squared and the negative x to the 4th. All right, so I'm kind of moving over to the left because I ran out of space. But when I find the antiderivative of 4x squared, I'm going to add 1 to the exponent, so my new exponent becomes 3, which means I multiply by 1/3 to that 4. So I get 4x cubed over 3. And I do the same thing for the negative x to the 4th. My new exponent's going to become to the power of 5. And so I multiply by 1/5. And I end up with negative x to the power of 5 over 5. Right? I am integrating from 0 to 2. So I can go ahead and plug in my b and my a value. In this case, I'll plug in the b. And when I do that, I replace my x's with 2, so I end up with 4 times 2 cubed over 3 minus 2 to the power of 5 over 5. In this case, if I was to plug in the 0 for x, everything would just cancel out, so I'm not even going to write it in. All right, I'd end up with 0 minus 0, which we know is just 0. Right? And so if I go ahead and actually solve this, when I do my multiplication, when I do 2 cubed and 2 to the 5th, multiply that 2 cubed times 4. Also, I'm going to go ahead and get a common denominator so that I combine these. Okay, when I combine them, I'm going to end up with, or when I get that common denominator, I'm going to end up with 160 over 15 minus 96 over 15 times c squared. And so when I solve for this, I end up with 64 over 15 times c squared equals 2. Okay, and when I'm going to go ahead and divide out that 64 over 15, right? And so, or you can think of it as divided out or multiply by the reciprocal, right? And so if I multiply 2 times 15 over 64, I do end up with 30 over 64, which does simplify down to just 15 over 32. I square root it to get c by itself, and I end up with the square root of 15 over 32 equals c, right? And there's my answer. I'm going to go ahead and do a different video for question 4, so I'll post that one next.